You're listening to Off to Market with Scott Farley and Hamish Chadwick.
Hi, I'm Hamish.
And I'm Scott.
And the theme this week is it's not the theme. We're talking about the engineering phase of the project. So, Scott, you might want to lead us in with that.
Okay, so take a seat, get a beer, because it gets a bit boring around this
stuff. Scott's been telling me this is the boring phase, but look, I don't know anything about it, so it's going to be absolutely amazingly fascinating.
Look, we ended off last week. Well, Hamish did a naming section in between, but prior to that, we were talking about the design phase, which is, I guess, the more exciting part of it. You know, you're uncovering new fields, you're discovering which way to go, and all the rest of it. It's quite exciting, and you know, when you come up with solutions, it can take a while, but when you get one, it's really quite satisfying. And then I guess now what we have to do is really make it work. So there's a step before the stage which I'll just quickly cover off, and that's a final concept, which I normally do, which really for me, it's probably not everyone does it, but I do it because it's much easier to do a sketch, or quicker to do a sketch than it is to do CAD. CAD is computer aided design, and that's what your models or your project is made into, and it's a computer program that makes a physical model of your, or not a physical model, a data model of your product. But I like to draw we come up with initial concepts which show the way to go, and then we find a direction out of that through market, what we've done in the market research and what the client wants and what our final goals are. And I like to do a final concept which really draws that part up, but really goes into nuts and bolts how it's made. And then I use that to develop CAD models, and by doing that stage, you sort of explore the ways things can be made. Because if you just plug into CAD, you can go round and round in circles trying different options for how the part's going to be made, how it's going to go together, how it's going to lock on, how it's going to lock off, all that sort of business. So by doing a sketch, you can sort of really conclude all those issues before you start on the CAD. So the CAD is computer aided design, as I mentioned, and so you model up all of the different parts of your product and assemble them so you can find out how they fit together, how they open, how they shut, all that sort of business. It's really time consuming, and it's a crucial part of the project because the CAD models are what you use to make prototypes and the tooling to make the parts and manufacture. So it's crucial, you can't get away from it. It used to be done in 2D, which was a nightmare because 2D is so easy to misinterpret. 2D drawings on a page used to be done with a draftsman. They were covered in black lines and drawings and dimensions, and you could barely see the actual part because there's so many notations on it. These days we do it in what they call 3D solid modelling, and we have to sort of get this 3D modelling software which allows us to do the part in a 3D model, and that means all the data for the part is captured within this data model, and that can be used to create 3D printed parts, mill parts. We do a lot of milled parts for prototyping, and also the tool.
Sorry, just when you say milled parts.
Yep. So there's milling machines that actually it's called subtractive prototyping, where they take material off a block of material, whereas 3D printing is additive, where they actually add the material to nothing, basically. So they just build it from nothing. Okay. It's a resin that's cured by laser or by UV light or whatever it might be cured by, and it just basically builds up off a platform. And it's called additive because each layer is adding to the next one. Okay. The subtractive is you take a block and you're taking material off to get your end result. So that's all crucial to CAD development. It's quite time consuming. Clients always say you can just make this little change, and I just about fold into myself because I know there's another 2 weeks worth of work involved in making that little change. But it's crucial. You have to do it. It's definitely one of the most laborious jobs. But you're still learning, so you can't really farm it out. You have to be the inventor or the designer has to be involved with it, because if you farm it out, it's going to get misinterpreted from the concept to the final. And there's certainly things you refine in that design through the CAD. So how a hinge works, how a locking mechanism works, or whatever. How two parts interact and snap together. So it's crucial, time consuming, but it's basically from this point on, the CAD development, it's the engineering phase. There's no more major redesign. can be small redesigns where you might have a feature you add in to make it, to enhance it or whatever, but you really don't want to be redesigning anything major at that point, because to change the CAD's incredibly
And I suppose
consuming.
Just to interject there, I'm sure everyone is enjoying all that.
I'm just trying to say, wake up.
No. It's all fascinating stuff. No, but it's interesting when you're talking about prototyping. Are you? And I've never had this discussion with you, but are you taking into consideration the image of the product or the brand of the product when you're designing? Because I know when you're talking about when you're looking at, say, top end products. What differentiates a very expensive product from a cheap product, and often it's the feel of it, it's the weight of it, it's the way something opens on it and shuts on it, it's the way it clicks.
Yes.
I mean, when you're looking at again, I think we've used this analogy before, we're looking at cars. If you have something like a Bentley or a Rolls Royce, they will spend a lot of time looking at how glove boxes open and close, the dampening on those sorts of things, the dampening on the mechanisms, because that's their whole image is reliant on every little piece in that vehicle behaving in a particular way. Is that what you're taking into consideration?
100%, yeah.
Okay.
It's sort of almost taken in at the concept stage, but because even the way you apply form to a product, more angular parts are masculine, more rounded parts are female, so you have to be doing that at the initial stages. So it's all thought all the way through. We'll even add weight to a product which is quite light, just to give it that feeling of quality. So there's definitely
fill it with lead.
A little bit of lead in there. But no, definitely even thicknesses of material. If you've got a real really highly commodity based product, you might have really thin walls on it, and a cheap material. If you've got a quality product, you'll have thicker walls, and you'll use a high end material with a better finish and all the rest of it. You can polish the tools or leave them with a fine smart finish or something. It definitely comes into it. Everything comes into it. When you pick up a product, there's probably 1,000 cognitive cues that happen when you pick it up, which relate to feel, softness, warmth, weight, how it clicks open, clicks shut, how the speed at which it comes open. We'll put binocular grease on certain joints to make them open in a certain slow fashion. Like your little sunglasses holder in your car. You push the button and it comes down slowly from the roof. That's just 2 gears with binocular grease on them, and so they don't want to turn as quickly as if they had no grease on them. So little things like that we add into it, and I'll design a mechanism around how I want it to act.
Okay,
100%.
That's very interesting. Then, so it's not a case of so branding and image management really happens at the beginning of these projects. I suppose if you're getting to an engineering phase and you've got no idea, that's obviously not the case. Someone is actually making decisions at that point.
Definitely.
So depending on, and this would relate with price more so than anything, is what price point would this product sit in, and what decisions can be made to make it look as if it is conforming to that price point. So if something is going to be a little bit more expensive, it has to feel more expensive, and likewise going the other way. Or if it's a mid-market product, it's not going to be either cheap or expensive. So there's a lot of perception management there.
100%. Perception is a big thing. There's a number of products you'll see on the market, and simply the way they're packaged, and that doesn't mean just the package they're in, but the way they're designed is also part of the package that is being produced. There's a very big part in the price point, where it sits in the market as far as price point goes. So we've definitely done lighting products where you can go to the hardware and buy a $50 equivalent, and we design it in different materials and different processes. Doesn't cost any more to make it, but it looks far more advanced, and you'll sell it for 4 times the price. It's just simply a way of positioning things in the market, and there's no reason you can't have 3 versions. The manufacturer might decide to do a top end version, have the same running gear and a middle end version, and the same gear and a low end version, just package it differently with different outers. So definitely comes into it. We've definitely had products, if you're going to a market where it's highly scientific, you may add totally irrelevant bodywork to that thing and different materials simply to make it look scientific, and you might be able to get away with doing exactly the same thing in a square box, but you'd be mad to, because the perceived value would be far less, and you couldn't sell it for what it's worth.
So to attract the geeks.
That's it. We had a mining product, and you could have just plunked a box on the outside of it, but we dollied it right up, put a nice case on it, and that was a $150,000 product. So you had to make it look.
And it's funny because if you went to those markets and asked them whether image was a concern, they'd always say no.
Exactly.
But really, when it comes down to it, everyone is concerned with image, and everyone is concerned with what they associate with. So it's all
in
very
that
important.
situation with engineering, people always say at some point a non-engineering person is going to buy that product, and it looks like rubbish, and it doesn't work well, and then he goes back to his manager or CEO and has to explain. The CEO is going to look at it. Look, it looks like rubbish. Why did you buy this piece of?
Well, I suppose that's the other side of branding too. Is who do you need that product to be sold to? So it's that's always an interesting one. Is you're not necessarily selling to the. It depends on who your economic buyer is. So it's another interesting comment about who you're trying to convince.
It didn't work. Was well, you couldn't be blamed. It looked great.
Yep.
Excellent. So I guess once you've done the CAD, you have the 3D models. You can actually then physically produce this product to test it. So there's so many different ways of doing that now. 3D printing is probably the most commonly known one now. It's become very popular in like popular culture. Everyone knows about it, but it's been around for a long time. I think 20 years ago when I started the consultancy, I did the first UAV for Boeing in 3D printed a 3D printing SLA process. And it's advanced a lot. Everyone says, now manufacturing is going to become done, and some manufacturing is done with 3D printing. There's certain things that are really efficient when you do 3D printing, but generally if you want to produce a really low cost product, you injection mold it or you die cast it or something or other, because it's just very quick. The setup is more expensive, but the parts way cheaper and much faster to make. I mean, if you look at if I looked at a cup, a typical coffee cup, you'd probably take 3 hours to print that. Whereas if you injection molded it, it'd be 20 seconds. So you can make hundreds of thousands in the time you can make 20 of a 3D printed part. So certain things where you've got internal structures, they're really good for. A lot of aeronautical parts are made with 3D printing, especially titanium printing, where they're trying to get lightweight and make a internal structure. You can't do that through general manufacturing processes because you can't get inside and take the tool out of it again without destroying the part. But if you want a really lightweight product, you mimic a wing of a bone of a wing and a bird, which is all very thin and fine and light and full of internal webbing. So you can do that with aeronautical product, which then makes that process efficient. But what we use it for is first of all testing. So if everything today, even the CAD is theory. You can test certain things in CAD. You've got section tools and even FEA tools to test structure and strain and stress and everything, and you can obviously make little animations to see how things clear when they open and all that sort of business. But in the end, it's still just a model on the screen, and you can't actually physically hold it and use it. You don't even know what size it is, really, to be honest, to a certain degree. So you make a prototype, and prototypes can be anything from. I've done things where I've grabbed a teat from the chemist and just put it into a bottle and see whether something would actually work. I call it a proof of principle, just to prove a theory. And they can be, like I said, a $2 teat from a thing to prove an idea, and they can go right up to a fully, functional, engineered and manufactured part that looks exactly like a final production part. But a proof of principle project is really useful. Quite often I do them and don't even show the client because they're pretty rough and ready, and I'm just proving that a certain thing's going to work. And then you can go to a 3D printed model. It's fairly cheap and easy. You can turn it around pretty fast, and you can get a fairly good idea of how it all snaps together and what it feels like in your hand. And then we work all the way up to, obviously there's different levels. You can do titanium. You can even grow, human membranes off a 3D printer. So there's lots of things you can do with it. But for us,
so that's what you're doing.
Not really. I keep well away from anything human. But we do
genetic engineering here.
No, we do a lot of. We've used a lot of milling in the past. So quite often we need to use the prototype not only to test it, but also to demonstrate it to a boardroom or create a video from, get market feedback. So it really has to look like the final manufactured part. So if you mill a part, you can use the materials that it might be manufactured from, and then you can have it painted, or you can just finish it in a way that looks pretty. You can make clear acrylic parts that are crystal clear. They come out of the parts crystal clear. They look everything like an existing, the final manufactured part. So a lot of times people pick it up and think, how many of these can I have tomorrow? And so, well, it actually isn't manufactured yet. Well, what is this? Well, it's a milled part.
Yeah.
So it's really, really useful for demonstrations. So I've had deals go ahead because the prototype's been so good, and others, I've seen other people come in with printed parts and they just don't get taken up, because quite often you're presenting to people who don't have the vision to sort of see past the single coloured raw cream fragile 3D printed part. They just can't see what the actual final product would be, even though you've got graphics with it and everything. So we find that putting a really smick final looking product, which is painted and beautiful in front of people, that the people can actually use and even go and test, really beneficial. And it is more expensive. It's about 30% more expensive, 40% more expensive. Takes a little bit longer, but the down the line benefits are enormous, and so it easily pays for itself. Really,
so again, you're really selling to different audiences all the way along your project. First of all, you're selling to yourself, I suppose, is the idea good enough. Then you're selling to someone like you, Scott, or someone like me. Are we willing to take on this project? And then all of a sudden, you're selling to investors, and then you're selling to people that might want to license it and take it on. So at every point, there's a design stage and an idea stage, but there's also a marketing process that accompanies that. Even if you don't want to acknowledge it, there will be a marketing process there.
100%. We've even used prototypes to secure orders. So you take your prototype along to your big retail chain and you put it in front of them, and you secure an order from that prototype. This is what it's going to look like when it's manufactured. It's going to how it's going to operate. You go and test it. You're happy with it. You go and even show your customers and test it and see if they're happy with it. If they're all happy with it, they'll actually put a memorandum of understanding that they'll take X amount of units, and you can actually even use that to bridge loan to do your tooling, pay for your tooling costs and things. That's how powerful that is.
Okay.
To do
That's interesting.
A very useful final prototype.
Okay.
Because that whole people can get themselves to a certain point, and then they almost always need some sort of help financially to get to the point where they can go and buy tools, which can be very expensive. Place the first order. People don't often consider that, but usually when you're doing mass production, you have to order, depending on the product, between 1,000 and 10,000 units generally, sometimes hundreds of thousands of units. I think the minimum order to produce a unique packaging for a beer bottle is 20 million.
Is it really?
to make it efficient, to buy it.
Yeah.
So you don't only make those sort of things, but the purchase of those parts can be something people don't budget for.
No.
And it can put them in a big hole.
Yeah.
But if you've got a memorandum of understanding to say that someone, a reputable company will take X amount if you fill the order, then you can go along to a bank and say this is what I need to do to get that point, and you may get a bridge loan for that, or then you go and see an investor and get an investor involved. But it's something that a lot of people don't think about. Yeah, if it's a $2 product and you've got to buy 10,000 of them, that's something you may not have budgeted.
It's a lot of money.
And that's generally not a $2 product, it's usually a $15 product. Yeah.
No, so the marketing process is vital. So
definitely. So further to that, 2D control drawings, in order to get the tools made, once you've done the prototype and you've tested it, everyone's happy with it, you can then progress to getting a quote for the tooling to make those parts. And so to do that, we always use 2D control drawings. 2D control drawings are more and more a stage people avoid or skip because it's cheaper not to do it. But we never skip it, and there's a few reasons for that. It's basically the recipe for how you make the part. So 3D models, although they can be annotated to a degree, the tool maker on the other end, you don't want them guessing about anything, where the part line is, what the finish on the product's going to be like, what colour, what percentage of how you're going to do the colour process, whether it's going to be master batch or powder batch or all the rest of it. All these things have to be controlled like a recipe on a 2D control drawing. They accompany the 3D data. You can actually just take the 3D data that I've produced the prototypes with and make a tool mold with it. But there's a lot of things in there, like what material is going to be running it, and that's going to affect the shrinkages, so they have to adjust the tool to make certain shrinkage for certain materials, so they need to know that. So if you don't have that on there, you're already behind the 8 ball. If you don't have the surface finish on it, you might get a gloss part when you wanted to find a nice satin finished part. There's 1,000 different things that need to be critical dimensions. Some things have to be critical, others don't. two mating parts might need a tolerance in there, you have to draw that tolerance on that drawing, so that the toolmaker's aware, I have to be very careful at this point and make those two mating parts correct. So there's all these things. If you avoid that step, and then you get the manufacturer to make these things, and you get a shipment of 60,000 of these parts on your doorstep,
and they're not
and
quite
it doesn't
right.
quite right. What document have you got to go back to them and say you didn't follow this step? You've given me gloss when I wanted fine spark finish or a satin finish. I find it a very important document, not only to guide the toolmaker, but also for legal ramifications if something goes wrong in the transport. Quite often these parts are being made overseas, and so your only chance of seeing them, even though you might use quality control people on the other end, your instructions to that quality control person is really all you're relying on. The container turns up on your doorstep, that's the first time you see it, other than maybe a couple of samples that come through. So really important step, very, very boring part of it all.
Well, I mean, yes, I know we joke and say that it is
crucial.
boring, but it's one of those things that has to be controlled.
Exactly.
It's like everything in this process with getting off to market is giving it some thought, making sure that you're covering everything, and that's why it's important to use experts and people who have done this before, because it can be a minefield.
Mass production, the little details are very, very important. So you can use those 2D drawings to go and get quotations. So we always try and get a variety of quotations. There's the go-to for most time, let's go to China and do it. Well, sometimes that's not the most efficient way to do it. I love to do everything I can here in Australia. It's not always possible. There's certain things we just can't compete against. But whenever I can, whenever I have a product or a service supplier who can compete, I always try and get them in the mix, because there's nothing worse than me having to go overseas to solve a problem. It's just expensive. It's disruptive. No one wins out of it. So if you can just drive up the road there and talk to your supplier, the benefits are enormous. You don't have exchange rate issues. If you're doing something in China 2 years ago when we had parity with the US dollar, all Chinese contracts are paid in US dollars.
Yes.
All China's interested in doing is bringing US dollars into China. And so every contract I ever deal with in China, except for maybe one of my contacts who's become very, very close associate, good friend, he'll sometimes quote me in Australian dollars, but every other supplier I've ever dealt with is US dollars. 2 years ago when we were at parity, your product was costing the same amount of Australian dollars as it was US dollars. Now that we're 0.75, you're paying another 30% for your product, and so that can vary all over the place. There's also things like insurance. Is your tool insured in another country? All that sort of stuff. It's a little bit out of your control. You're very much over the barrel when it comes to how you get that part back or the tooling back and everything. So you've got to consider all these things holistically, and I'll sit down with my clients and I'll just look at all the different options. We'll get 3 or 4 different quotes from different sources, internally and externally, and we'll sit there and we'll just toss up the pros and cons on each, and quite often you'll find that doing it in Australia can actually work out better.
And just a really interesting point, Scott, I'm not sure whether you're aware of it, but just talking about a well-known fishing brand that we have had dealings with, a lot of people said, why don't they just take their tooling to China to get it manufactured there? So taking the equipment from here to China, the other way around. Apparently you're not allowed to do that. In China, they have a law which prevents you from doing that. You have to actually get all your tooling done in China if you want to manufacture in China. Is that correct?
I don't know that law. I've definitely
not a law, but it's certainly that's
their preference. Of course, they want to do the tooling in China.
Yeah.
There is some issues sometimes bringing your tools out of China, because there's really, when you specify your tooling in China, you have to specify either export or internal, because if you design a tool in China and you don't specify it has to be export quality, then you might have a process in there that they put a manual process into it rather than an automated process. So because labour is cheap in China, you can quite often substitute a person for a mechanism. And so, if you go to bring that part across here, you won't be able to run it efficiently, because you've got a guy standing there or a lady standing there the whole day just operating a mechanism that would normally be done here automatically. And also some of their machinery is a little bit different, so it won't fit into an Australian machine. So you have to be a little bit careful about bringing tools out of China, and also specifying the type of tool you want made in China, especially tool steels and everything can vary a lot up there. But I don't know of any rule that you can't take it up. But I do know of some rules where there's a bit of ambiguity. If you do design in China, sometimes that can be a little bit dodgy as far as who owns the rights to that, even if you've got a patent. So I'm not a lawyer or an attorney, so I can't really talk about that too much, but I know you have to ask someone about that.
I think all we're doing here is making sure
highlighting some issues.
We're highlighting some issues, that's right. No, but I just think it's a bit of a throwaway line, has been for a number of years, is if you want something done that's cheap, just simply go to China. But I just think from talking to you over the last few months and other manufacturers that I deal with, it's not as straightforward. It's not a case of just saying, great, let's just send it to China. I think there's a lot involved. Doesn't matter where you send it.
I think it's smart to do all your design work here, not let the external parties do any of the design, because then of course you've got this who owns the idea happening going on. So very good to get people who are sitting beside you to do the design work. I think it's much easier to translate across and then send that finalised design and control drawings and data all finished and tested up to China. Don't try and do the design stuff up there. I think it's wrought with danger. That's pretty much once you get the quotes back, of course then you basically have to try and finance it. So unless you've sort of got the money aside, you need to sort of go and try and do some commercialisation work to make sure that you can justify spending the money on tooling. And you really should have been doing that a little bit earlier than almost at the concept stage. You're proving the market wants it, you're doing the prototype, you're proving that it works, you've solved the problem, you've got your patents in place, and then you go and talk to commercialisation entities, which is a whole other game, which we might even address at another time, you think, or another podcast.
Yeah, let's do that. I think people have...
it's a big game, that one.
Yeah, I think people want to grab a coffee and...
So that's the boring part of product development, and it's boring for me too, don't worry. It's very laborious.
No, it's all fascinating.
And it's tough, hard yards after you get past the design period. I'm a creative person, so I enjoy the design aspects, but the engineering's just hard slog.
Yeah.
but crucial.
Absolutely crucial.
As you probably found out through that.
All right, so let's in the next episode we'll talk about
commercialisation, manufacturing, trade agreements, partnerships, and how you make some money on this product. And whether it was actually worth doing or whether you should have gone on holiday.
Yep. Rivers of Gold next week.
Perfect.
You've been listening to Off to Market with Scott Farley and Hamish Chadwick.